Hi, and welcome back to Null Zero Labs. Today, I'm going to show you the poor man's MPLS, a way to create a layer 2 connection between two locations over a layer 3 connection. That means the internet, some kind of MPLS service provider, anything that's got a layer 3 connection. We're going to take these layer 2 packets, we're going to stick them inside an L2TPv3 packet. We're going to then shove it inside an IPsec and send it across the internet to the other side, where we're going to unpack it all and spit out layer 2 frames again, just like normal. So let's jump into the lab and I'll show you the magic sauce and how we can get this working. So here we are in the lab. Now I've segregated it into two blocks to differentiate between layer 2 and what is layer 3. So as we can see here, layer 2 down here is our switching network. So we have our two switches. We have a port G0 on each switch that is configured as a trunk interface, and it is allowing VLAN 200 on that trunk. We have our access interface on G01 towards our two clients, desktop and desktop 2. They are switch port access mode, and they are configured for VLAN 200. We then have our two desktop clients, which are connected to those ports, and they are in the same subnet. So 192.168.10.10, 192.168.10.11. So both of these PCs are in the same subnet. If this PC was connected to switch 3 on another switch port access port for VLAN 200, they would be able to communicate. But as you can see, we need to be able to get layer 2 connectivity between these two devices, but we only have a layer 3 gateway up here. So we have our pseudo fake internet service provider here. We have our public interfaces. So we're going to configure our external interfaces. We're going to configure a xconnect interface on G02 on each of these routers. And we are going to create a tunnel interface between the two devices. And we are going to put some IPsec policies in place to encrypt any traffic that transverses that tunnel. We're also going to create a couple of loopback interfaces on each of these devices that we're going to use for our xconnect endpoints. And we're going to connect from router 1 to router 2 through the tunnel to that endpoint. And likewise, router 2 connects to router 1's endpoint through the same tunnel. And what we're going to do is we're going to take our layer 2 packets, we're going to wrap them up in an encapsulation, and we're going to then transmit them securely over the internet to the other side, where we can then spit them back out as layer 2. And these two devices down here will have no idea that they're communicating over a layer 3 network. And what we'll do is we'll capture some of the packets on this external interface to show you that they are indeed encrypted, so that anybody out there on the man in the middle or on the internet cannot read them. So I've got my notes here to the side because we've got a lot of crypto map stuff to put in, and it's always hard to remember those things. So let's start with router 1. And then what we'll do is we'll duplicate pretty much a similar configuration on router 2, apart from a couple of IP address changes, and then we'll be able to test reachability between these two devices. So first, let's have a look at the switch, just so that you can see the configuration we have on the switch. So if we do a show VLAN, there we go, you can see we have VLAN 200, and if we do show run int G0/1, we can see our interface towards the client is just a standard switch port access VLAN 200, and our show run int G0/0, our interface towards our layer 3 router is just a trunk port. This can also be an access port if you're only spanning a single VLAN across, but we're going to do a trunk port because we can add some more VLANs later to go across between the two. So let's jump onto RTR1. It is booted up. I will move myself over to there so we can see the configuration, and whilst I'm configuring it, so if we put it there, okay. So let's go into enable mode. Let's set the host name so we know which one this is. This is RTR1. And let's start by setting our outside interface address. So int G1, description, internet. Our IP address is 192.168.68.241. And it's need to add the address, IP address, perfect. And we will no shut that interface. So that is our external public interface configured. I'm going to create a loopback interface for our xconnect. So that's going to be int L100. In the description, this is going to be our xconnect point. And it's going to have an IP address of 10.10.10.1. 255.255.255.255. So /32. And again, I've forgotten to enter IP address. IP address. There we go. And we will no shut that just to be sure, but we shouldn't have to because it's a loopback. So that's our two interfaces there. Next, we're going to create our L2TP class. So we're going to go L2TP class. I'm going to call it xconnect L2TP. And we're going to set authentication, and we're going to set a password of null 0 labs. So that is our L2TP class. So what we're saying is that if anything uses this class, it's going to be secured with authentication, and the password is null 0 labs. Next, we're going to create a pseudo wire class. And I'm going to call this xconnect pseudo wire. That's the name of it. We're going to encapsulate it using L2TP v3. That's the key part here. We're using v3. And then protocol is L2TP. And we're going to use that class, xconnect L2TP. There we go. And then finally, we're going to set our IP local interface is going to be that loopback that we already made, which was loopback 100. And then we're going to set our IP PMTU, and that's it for our two pseudo wire classes and our L2TP class. Now, because we're encapsulating protocols within protocols, our MTU size may grow bigger than 1500. So we're using the PMTU to calculate the MTU path along the chain. And later when we set up our tunnel interface, we'll lower our MTU size down to 1400 so that our packet size is slightly smaller so that we can fit within that 1500, possible 1500 limit depending upon the type of networks that we're crossing. Obviously, once it gets out onto the internet, you can't guarantee that you're going to have jumbo frames or mini jumbo frames. So that's our two classes for our encapsulation done. Next, we're going to create our crypto map. So our crypto map is going to be, we'll call this policy 10, and the encryption is going to be AES 256, and our hash will be again SHA-256 will be fine. Authentication is going to be a pre-share key, and we're going to use Diffie-Hellman group 14. So that's for that. Next, we're going to create our pre-share key. So our crypto phase 1 key is going to be null 0 labs. Again, remember to make sure it's something more secure. And then we're going to say when we're connecting to 192.168.68.242, which is going to be the public IP address of the router of the other side of this connection. So we're going to use that. Next, we're going to need a transform set. So crypto IPsec transform set. Let's give it a name. Let's just call it TSVTI. And it's going to use ESP-AES-256 as well. All the 256s. The mode is going to be its transport. Now we need a IPsec profile. So IPsec profile is going to be VTI. And we're going to use that transform set of transform set of TSVTI. So we've got our xconnect L2TP profile. We've got our pseudo wire profile. We've created our crypto transform set, our policy, and our IPsec profile. We've created our loopback interface, and we've set our outside interface public IP. So now we're going to create our tunnel interface. So int tin tunnel 1, and we're going to say this is IP unnumbered to our public interface. We're going to set our MTU to be 1400, so it's lower, so we don't cause our packets to fragment. We're then going to set our tunnel source as the other side of the tunnel, so that's going to be 192.168.68.242. We're then going to set our tunnel mode as IPsec IPv4. And then we're going to set our tunnel, our tunnel source is actually 68.241, which is our IP address. And our tunnel destination is going to be 192.168.68.242. And then our tunnel protection is going to be IPsec, and our profile is going to be that VTI profile that we created earlier. So we will no shut this interface. So we've now got, if we do a show run, we have our L2TP class where we've set an authentication password. We've created our pseudo wire class where we're saying that anything that we're doing with xconnect, we're going to encapsulate it in L2TP3, and obviously it's password protected, and it should be coming from or to the loopback IP address of the device. We've then set our crypto policies and said what our pre-share key is to connect to the remote side. We have our xconnect interface. We have our tunnel interface. We have our interface to the internet. And now we're going to set our IP route. So the other xconnect interface is going to be 10.10.10.2. And that's going to be 255.255.255.255. And we're going to send that through tunnel 1. So to reach this IP address, you have to go through the tunnel to get to it. And obviously anything going through the tunnel will be encrypted with the IPsec policy that we set up. So let's now configure interface G2 here on the router. So int G2, and this will be our xconnect interface. Towards our switch, and it's going to not have an IP address, so no IP address, no keep alive. Negotiation will be auto anyways, we don't need to worry about that. So now we're going to go xconnect to 10.10.10.2, and we're going to set a VC ID. We're just going to use 100 for ours. Then we're going to set the encapsulation. So we want to encapsulate this into L2TPv3. And we're going to use our PW class that we created, which was xconnect-PW. So there we go. And we'll no shut this interface just to make sure that it's not down. So let's write this config. Let's do some basic checks. Show int status. Nope, this is not a switch. Show IP int brief. Okay, so we can see our interface towards the router, towards the internet is up. We can see our xconnect interface towards our switch is up. We can see our loopback is up and configured, and we can see our tunnel is partly up, but it's not reaching the other side. So show xconnect all. We can see that our xconnect to the other side is currently down. Show L2TP tunnel, and we can see our current tunnel is down. So we have no L2TP tunnel to the other side. We have no xconnect to our other side. So what we're going to do now is we're going to jump over to router 2, and we can copy bits of the config from router 1 over to here to make it simpler. All the interfaces are the same. So we'll start by configuring the public interface, the loopback interface, and then we'll then copy some of our policies over, and we'll copy our crypto map information over, and then we'll create our tunnel interface back towards this device and create our xconnect interface towards our switch. So let's jump onto, let's just make sure we did save that. Let's jump onto router 2. So first of all, let's set our host name as RTR2. Good. Right, let's set our int G1, which is our public interface here, and we're going to do 242. So description, this is internet. IP address is 192.168.68.242. No, shut. So that's our public interface. Int L100, which is going to be our xconnect point. And that's going to have an IP address of 10.10.10.2, 255.255.255.255. No shut, just to be on the safe side. And now we can pretty much copy our profiles over, because they are going to be the same for our L2TP class. There's no point in retyping the same thing. So we create our L2TP class and say that this class uses authentication. We're then going to create our pseudo wire class that says that we're going to use L2TP encapsulation, and it uses that profile so that we can encrypt it. And we want our IPMP, that's correct. So that's our two profiles. Next, we're going to need our encryption. So our phase 1 is going to use this information, and our is going to be a pre-share key. And we're going to want the same pre-share key, except this time we are talking back to 192.168.241. And the transform set and the profile are the same. So we can just steal those over. Perfect. So what do we need now? Let's do a show a run. So we have our transform set for L2TP, and we have our pseudo wire class. We have our loopback interface, our interface towards the internet. Now we just need our tunnel interface. So int tun1. This will be our tunnel interface. Again, this is going to be IP unnumbered to our public interface. Our MTU is going to be 1400. Our tunnel source is going to be 192.168.68.242, our public IP address. Our tunnel mode is going to be IPsec, and it's going to be IPv4. And our tunnel destination is going to be 192.168.68.241. And our tunnel protection is IPsec using profile VTI. We will now shut that interface. We should see that the tunnel has come up. So now we will IP route 10.10.10.1 255.255.255.255 is available via tunnel 1. We can just test that quickly. Ping 10.10.10.1. There we go. So we can reach the other side through the tunnel. So now let's do the final configuration. Let's configure our G2 interface. So int G2, int G2, G2 even. No IP address. It's going to be our xconnect interface towards our switch. No IP address, no keep alive, and we're going to do xconnect to 10.10.10.1. We set a VCID number of 100. We're going to encapsulate it using L2TP, and we're going to use a PW class of xconnect -PW. I'm going to no shut this interface. We can see our pseudo wire interface has come up. So that's our fake layer 2 interface. So we're going to exit. Let's save this. So that should be it, as long as I haven't forgotten anything. So let's go and do some verification. So if we jump back over to router 1 and we do a show int IP int brief, we can see we've got our interfaces up that we're using. Show L2TP tunnel. There we go. We can see our tunnel is established from router 1 to router 2 using our xconnect class. Show xconnect all. There we go. We can see our xconnect interface is up. So this segment 1 is up and across to our L2TP tunnel to point 2 is up. Show IPsec crypto IPsec SA. We can see our IPsec is encrypting and decrypting packets. So we can see the encryption is active. So, and if we just ping 10.10.10.2 with a source address of the loopback 100, we can see that we have IP connectivity through the tunnel. So our 2 tunnels are up. Now we should be able to jump onto our desktops and send traffic across to desktop 2 as if they're on the same LAN. So now let's jump onto our first desktop. Let's bring them both online and we'll send traffic in both directions. Let's make sure the network interfaces come up on our desktops. Settings. You are connected. Should have a manual IP address. Okay. Terminal. Ping 192.168.10.10. Okay, so desktop 2 is able to ping desktop 1. Open a terminal on desktop 1, ping 10.10, nope, ping 192.168.10.11. There we go, we can see it's pinging. So we have both of our machines pinging each other. Let's go and have a look as if we were on the internet trying to capture our traffic. So if we look at our outside interface, we pull up Wireshark, we can see that all the traffic going between the two devices is encrypted. So it cannot be read. It's encrypted, encapsulated payload. There we go. So we have securely created a tunnel and our layer 2 traffic is traveling between that. Let's stop that. Let's capture on the G2 interface. So let's do a capture on G2. So this is before it goes through the encrypted tunnel. And there we go. We can see the traffic pinging 10, 10, 10 to 10, 10, 10, 11. So we can see our replies. We can see our layer 2 ARP traffic. So all of our Ethernet layer 2 traffic is here. We can see our ARP requests, CDP. So if I was to stop this Wireshark now, and I jump back onto one of our switches here, and I do a show CDP neighbor. There we go. We can see switch 4 is connected via G0/0 to G0/0. It believes it's connected at layer 2, when in fact it's not. It's been packaged up, encrypted, sent across the internet, coming back out the other side, and these devices down here have no idea that it's happening. So there we go, a quick, simple, easy one this week. I hope you enjoyed that. It's a handy, useful tool to have in your tool belt in case you ever need to create a secure layer 2 connection between two locations securely when you only have either the internet access or some other form of public layer 3 connectivity. There we go. I hope you enjoy that. Like and subscribe, and I'll see you on the next video.